On October 14, 2017, planet Earth continued its silent orbit around the Sun, oblivious to the fact that, for the first time in recorded history, the frontier of our solar system had been breached by an intruder from the deep abyss. For days, a strange object crossed our space, passing at a distance that, on a cosmic scale, was equivalent to a whisper in the ear. No one noticed. No one knew that the laws of our neighborhood were being tested. It was only 5 days later, when the object was already on its exit trajectory, fleeing toward the stars at an overwhelming speed, that our electronic eyes finally caught it. The result was a frantic race against time. Astronomers around the world diverted their telescopes from distant galaxies and black holes to focus on a single point of faint light moving far too fast to be a local inhabitant. The name given to it was Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But as the data came in, the messenger revealed itself less as a common asteroid and more as a physical anomaly. It didn't behave like a rock, it didn't look like a comet. It was something new, something that defied our classification and, upon leaving, left behind a question that science has yet to answer. Did we just miss the first sign of intelligence beyond our own? Everything we know in our solar system follows a predictable choreography. From Mercury to the far reaches of the Oort cloud, all objects are slaves to the Sun's gravity, moving in closed elliptical orbits, slightly flattened circles that ensure no matter how far a comet goes, it will one day return. But when Robert Warwick, using the Pan-STARRS 1 telescope in Hawaii, processed the trajectory data for this new object, the mathematics revealed something impossible. The orbit was not an ellipse. It was a hyperbola. In celestial mechanics, a hyperbolic orbit signifies only one thing. The object possesses excess energy. It is not bound to the Sun. It came from interstellar space, shot through our system like a bullet train passing through a small town station, and it will never return. Oumuamua was traveling at a cruising speed of approximately 26 kilometers per second before entering our zone of influence. To put that in perspective, if it were an inhabitant of our system, the Sun's gravity would have slowed it down long before. But it was a castaway from another stellar system, possibly coming from the direction of the star Vega, though later calculations suggest it may have been wandering the void for hundreds of millions of years. The impact of this discovery was seismic. For the first time, we had a physical sample from somewhere else. We were used to studying distant stars through light, but now we had a tangible object that had passed through our Sun's habitable zone. However, the euphoria of discovery soon gave way to perplexity. As telescopes across the globe, including the Very Large Telescope in Chile, attempted to profile this visitor, they realized it did not carry the characteristics that define long-range visitors. It had no tail. It was perfectly clean, a sterile traveler crossing the vacuum. When we think of asteroids, we imagine misshapen space potatoes. When we think of comets, we imagine dirty snowballs. Oumuamua was neither. The first clue to its bizarre nature came from its light curve. As the object rotated on its own axis every 8 hours, its brightness varied dramatically, by a factor of 10 between its brightest and darkest points. In geometry, this is only possible if the object is extremely elongated or extremely flat. Models suggested that Oumuamua had a shape similar to a cigar, or, as some physicists now propose, a pancake, with an aspect ratio of about 10:1. In billions of years of astronomical observation, we have never found a natural object in our solar system with such a disparity. Most asteroids have a ratio of 3:1 at most. An object 400 meters long but only 40 meters wide is a structural anomaly. If it were a simple rubble pile held together by gravity, like many asteroids, it would have disintegrated under the forces of rotation. This suggested that Oumuamua had immense structural integrity, composed of materials much denser or more rigid than normal, perhaps metallic rock or something even more exotic. Beyond its shape, Oumuamua's surface was strangely reddish, a hue indicating prolonged exposure to cosmic radiation for millions of years in deep space. Yet, it was surprisingly reflective for something that should have been mere stardust. The metallic sheen and almost artificial geometric shape began to raise eyebrows in the world's most prestigious astrophysics departments. Why would something so different from everything we know in our cosmic home decide to pass exactly through the center of our system? Was it a fragment of a destroyed planet, a sliver of pure hydrogen ice, or, as the shape suggested to boulder mines, a structure designed to minimize impact with interstellar dust? The anatomy of Oumuamua provided no answers. It only expanded the mystery, setting the stage for the most inexplicable behavior of all, which would occur as it began to move away from the sun's heat. On the vast chessboard of the solar system, all players must follow Isaac Newton's rules. When an object approaches the sun, it accelerates due to gravitational pull. When it moves away, it decelerates, like a ball thrown upward that loses strength as Earth's gravity pulls it back. Oumuamua, however, decided to cheat. In June 2018, a team of astronomers led by Marco Micheli of the European Space Agency published data that left the scientific community in shock. By tracking the object's exit trajectory, they discovered it was moving faster than solar gravity allowed. There was an additional acceleration acting on Oumuamua, an extra push that moved it away from the sun with constant mathematical precision. In astronomy, we call this non-gravitational acceleration. The immediate natural explanation for this phenomenon would be the rocket effect, common in comets. When a comet approaches the sun, the ice on its surface sublimes, turning into gas. This jet of gas acts like an engine, pushing the object in the opposite direction. However, there was a colossal problem with this theory. Oumuamua had no tail. No dust cloud, no gas trail, and no sign of water vapor were detected, even by the most sensitive infrared telescopes, such as NASA's Spitzer. If it were expelling enough gas to generate that acceleration, the brightness of the dust around it would be impossible to ignore. Furthermore, a gas jet would have drastically altered the object's rotation, making it spin like an out-of-control top. But Oumuamua maintained its rhythmic and stable rotation. We were facing an invisible motor, operating without apparent fuel and leaving no trace. It was in this vacuum of natural explanations that the most audacious voice in modern science emerged. Dr. Abraham Avi Loeb, former chair of the astronomy department at Harvard University. Loeb proposed what many of his colleagues considered a scientific heresy, but which, mathematically, fulfilled all the requirements of the mystery. He suggested that if Oumuamua was not a comet and not a common asteroid, it could be a solar sail of artificial origin. The solar sail concept is a technology that humanity itself has recently begun testing. It is based on the fact that light, although it has no mass, possesses momentum. When photons from the sun hit a highly reflective and extremely thin surface, they exert a tiny but constant pressure. In the vacuum of space, this pressure is enough to accelerate an object to immense speeds without the need for a single drop of chemical fuel. Loeb argued that Oumuamua's non-gravitational acceleration was perfectly proportional to the surface area facing the sun, exactly how a thin solar sail less than a millimeter thick would behave. This would also explain the object's bizarre shape. If, instead of a cigar, Oumuamua were actually a disk, a geometric and reflective pancake, its variation in brightness and its acceleration would make perfect physical sense. The scientific community reacted with fierce skepticism. Alternative natural hypotheses were proposed to avoid the alien conclusion. Some suggested the object was a hydrogen iceberg or a solid nitrogen fragment ripped from a Pluto-like exoplanet. These theories would explain the acceleration without a visible tail, as hydrogen and nitrogen would evaporate invisibly to our telescopes. However, Avi Loeb pushed back, proving that a hydrogen iceberg would not survive the millions of years' journey through interstellar space without completely evaporating under stellar radiation. The debate over Oumuamua became a battle between the improbable natural and the impossible artificial. Were we looking at a piece of exotic space junk or a robotic scout sent by a civilization that has mastered the stars for eons? Without a close-up image, Oumuamua remains astronomy's Rorschach test. What you see in it says more about your beliefs than the reality of the object. Oumuamua is currently moving away from us at a speed of approximately 40 kilometers per second relative to the Sun. It has already crossed Neptune's orbit and is entering the frigid region of the Kuiper Belt, where sunlight is but a pale glimmer. For our current telescopes, it is invisible. But for a group of scientists and engineers from the Initiative for Interstellar Studies, I4 is. it remains the target of an unprecedented mission, Project Lyra. The challenge is monumental. How can we catch an object that already has a years-long head start and moves faster than any probe we have ever launched? The answer requires planetary navigation bordering on perfection. The current plan envisions a 2028 launch, utilizing a series of gravity assists, the famous slingshot effect. The probe would swing by Earth, Venus, and Jupiter to gain the necessary energy. To reach interception speed, scientists propose an even more radical move, the Oberth maneuver. The probe would dive toward the Sun to fire its engines at the point of closest approach, perihelion, where fuel efficiency is maximized by the depth of the gravitational well. If launched in 2028, the Project Lyra probe could reach Oumuamua between the years 2050 and 2054. It would be decades of travel through the absolute void for an encounter lasting only a few hours. But the prize is inestimable, a high-resolution photograph that could reveal solar panels, antennas, or simply the porous surface of a hydrogen iceberg. It would be the end of the debate and, possibly, the beginning of a new era for science. Oumuamua taught us that the solar system is not an isolated island, but a port of call. Statistical estimates based on its detection suggest something astounding. There may be thousands of interstellar objects crossing our solar system at any given moment, most of them too small and dark to be detected by our current technology. In 2019, Comet 2I/Borisov became the second confirmed interstellar visitor. Unlike Oumuamua, Borisov was an open book. It had a classic tail, emitted gases, and behaved exactly like an expected comet. This made Oumuamua even stranger by comparison. If Borisov is normal, then Oumuamua is the absolute exception, the anomaly that refuses to be explained. We are about to open a new window into these mysteries. With the inauguration of the Vera C. Rubin Observatory in Chile, equipped with the world's largest digital camera, we will be able to conduct the Legacy Survey of Space and Time, LSST. This telescope is expected to detect dozens of interstellar objects every year. Perhaps we will discover that Oumuamua was not a unique event, but the first of a class of objects that Avi Loeb calls galactic technological junk, extinct probes or debris from civilizations that disappeared millions of years ago. Space may be teeming with interstellar archaeology, just waiting for eyes sensitive enough to see it. Oumuamua came and went like a ghost in the night. It didn't send us a radio message, didn't try to land, and didn't alter Earth's destiny. However, it changed Tudo. It reminded us that the universe is vast, ancient, and full of secrets that do not bow to our expectations. Whether it was an exotic rock sculpted by natural processes we don't yet understand, it expanded the frontiers of our astrophysics. If it was an artificial construction, a solar sail launched by intelligent hands in a distant star system, it was the most important handshake in history, one we almost missed because we were looking the wrong way. Regardless of its nature, Oumuamua was a wake-up call. It proved that the out there can come here. While Project Lyra remains on paper and telescopes scan the sky for the next intruder, we are left with a lesson in humility that only the cosmos can offer. We are a young civilization in a universe full of silent travelers. And the next messenger may be crossing Neptune's orbit at this very moment, carrying the answer to the deepest question of all. Until we find it, we will keep looking into the infinity, waiting for the next visitor who decides to cross our small, blue piece of eternity.